All right, this is the Algebra 2 Unit 9 review video. I'm going to go over a question of each type, show you the calculator you need to use, because you will be able to use all the calculators you see on this video on the test. First one is the mean, variance, and standard deviation calculator. This is linked in the video for that unit. I've already entered everything in, kind of make this video a little bit shorter, but I've taken the numbers from the first set, 8, 9, 11, 15, and 19. I put them into the calculator, and then I'm going to run this calculator twice. I'm going to run it for standard deviation, and I'm going to run it for variance. We'll do variance first. We just hit calculate. You can see the work that's required to get this is all shown here. This is why we're using a calculator. We don't need to go through that whole entire process. First things first, it gives you the mean at the very beginning of all of this work. The mean is 12.4. Let's write that down. And the variance is down here at the bottom, 20.8. We're going to run the calculator one more time using our standard deviation option. And while I'm doing that, variance is a measure of how far apart a group of numbers are spread. Are they very close together, or are they spread very far apart? And the standard deviation tells you sort of a way of measuring how far a number is away from the mean of a group of numbers. So that's going to be right here. This symbol here is the symbol we use for standard deviation. So we're going to round this off at 2 decimal places. So 4.56 is going to be the standard deviation. I'm going to make my thing a little bit less. There we go, 4.56. And that's pretty much it. So you run the calculator twice, once for variance, once for standard deviation, and you're done. Next, we're going to look at what's called binomial probability. This is when you have an event that is a 50-50 shot, and you want to know what's the probability of it happening a certain number of times. So in this first problem, it says, what's the chance of getting heads 5 times out of 15 tries? Now, the calculator looks like this. You got 3 things you need to put in. You got to put in the trials. That's how many times you're going to flip that coin. In this case, we're flipping it 15 times. We want it to be heads 5 times. That's why we put 5 under successes. And we want it to be a probability of 0.5 because that's the probability of a coin flip. All of the problems on this are going to be 50-50, so you put 0.5 for the probability. And then we just calculate. When we do that, it's going to run some numbers. Down here is showing you all the work that went into finding this. Be grateful for the calculator because you didn't have to do all this. And our probability is right here. The probability of exactly 5 successes is, and we're going to round off at 4 decimal places, 0.0916. And that is that. The rest of this is the same. Number of successes, total number of trials, 0.5 for the probability, and work it out. And I'll post the answers in the Google Classroom for the rest of those problems as well. All right, looking at the third set. This is pretty straightforward. It's really conceptual. You need to know that in order to find the total number of combinations of something, you're just going to multiply the number of options for each type of thing. So we have 2 kinds of crust, and we're going to multiply that times 7 different cheeses, and we're going to multiply that times 6 different meats, and we're going to multiply that times 6 different vegetables. And if I multiply all of that together, it will tell me the total number of possible pizza combinations. So 2 times 7 times 6 times 6 is 504. And so that is the number of possible pizza combinations that you could have. The rest of this page is basically the same, different sets of options, but the idea remains the same. Multiply each number of possibilities, and that tells you the total number of possibilities. Next is what's called a expected value problem. For an expected value problem, you are going to make a little group for each situation within the problem. So in this problem, it says that there's these dolls that are being made, and 6 out of 400 of those dolls are rejected because they are not correct. They're messed up somehow. They have imperfections, it says. And those cost negative $3, or they cost $3, which mathematically is negative $3. That is group one. Group one, we have a fraction representing the number out of the total, and then the cost of those. And then we're going to add that to the other ones. Now the other ones are going to be the other 394. There are 394 that aren't messed up, and they make $1.75 per doll. So that's a positive value because that's the profit for those. And when we combine all of this, we will get a number that represents how much each doll is worth, because they're taking into account the fact that some of the dolls will be messed up. So we're going to just put all this in the calculator real quick. Go down to the next row. 6 out of 400 times negative $3 plus 394 divided by 400, 175. And we get 1.67875. We're going to round off to the cents, so we're going to round off here, so it'll be 1.68 when it's rounded. And so each doll has an expected value of $1.68 in profit. Excuse me. All right, last set. Pretty straightforward here. You have a table. You need to decide, is it linear, quadratic, or exponential? And then you need to do a regression model. There is a link for each type of regression model, including exponential, which is the one we're going to use, and I'm going to explain why. The reason we're going to use exponential is because for it to be linear, we would need the numbers in the y to increase at the same amount each time. Notice these numbers increase by different values. They're not all going up, 5, 5, 5. They're going up by different amounts. That's why we know it's not linear. That's why we know it's not linear. We know it's not quadratic because quadratics either go up then down or down then up, and these are going up the whole time. Lastly, we know it's exponential because they're increasing, but the increase is actually itself getting bigger. So I'm going to put all of this in to Desmos. So let me go over here onto the link that I provide. I provided this on the videos, so you just use that same one. 2, 4, 6, 8, 10, 12, I think it goes to. Oh no, 10, 12, 16. And then over here I'm going to put the values. So 25, 36, 52. I'm just entering all this data. 68, 85, 85, 104, 142, 160. Oh no, 260. All right. So we can see it's, I don't know why my graph is doing this weird thing, but you can see the graph provided. But what's important is this information down here. In particular, the A and the B values are what you need for your answer, because the A and the B value are going to fill an equation in the form A, B to the X. And so our A value is 26.84, and our B value is 1.15. Put it all together, you get y equals 26.84 times 1.15 to the x, and your equation should look something like that. It might be rounded when you look at your answer choices, but you should be able to figure out which one is the correct answer. That's what's going to be on the test. The other stuff is vocabulary, which is at the bottom of the study guide. Study those terms, make sure you know those definitions, and you should be good to go.